Hello college algebra student. This video is for chapter 5.8 part 2. We're continuing with modeling change of two quantities or multiple quantities by the concept of variation. So we cover direct variation, inverse variation between two quantities. We're moving on to something called joint variation, where the variation occurs when a quantity varies directly or inversely with multiple variables. So we are no longer limited ourselves to x and y only. But they will be varying with multiple quantity. An example would be like if you find volume of cylinder, it changes when the radius change and also the height change, right? So this is the same idea. We could have the one quantity, but it varied with multiple, and some of them vary inversely, some of them directly. Now we do not add them. We use only one variation constant k, and it is all multiplying together. So it goes like this: a quantity y vary jointly with x and w. Okay, jointly with. They didn't say anything about inverse, so you do the same solving a variation problem is to write the model. Y is equal to 1k, but jointly with x and w, that means both of them are direct. So you will not have k1 and k2, you just say k, x times w. Okay, and then you solve for k, the second step. To solve for k, you would use one set of data that you have. When x is 60, when y is 60, x is, so you say k, x is 6, and w is 4. So then would be k times 24 is equal to 60, right? K would be 60 over 24, and if you simplify it, it would be 5 over 2 or 2.5. Okay, so and then the third step is you always have the equation right. You put it back in here, you say 5 over 2 xw. So whenever you give me x and w, I can solve for y. If you give me y and x, I can solve for w. So here, find the variation and find y when x is 4. The fourth is to find y when x is 4. So you will plug in 4 here, and w is 8. So this would cancel as 16 times 5 equal to 80. That's how you do the first example. The second is a little bit complex. It has very directly with square of x. So directly, so you say y equal to kx squared, and joint variation always involve another variable inversely with c. So whenever we do inverse, it's always divide. So we just say divide, but using the same k. Okay, so this is the first step where you translate the statement into an equation. The second step would be if y is equal to 40, then x is, we don't know what k is, x is 4, so which is square it, and then z is 2, right? So then we would have 40 equal to k times 16 over 2. This is 8. So k would be 40 over 8 equal to 5. We can write the model back. Y is equal to, this is step 3. Step 3 is when you actually have the equation times x squared over z. So now solve a problem. Find y when x is 10. So we will say 5 times 10 squared over 25. So 5 times 10 squared is 5 times 100. 100 over, so times 5 is 500. 500 over 25 would be 500 over 25 is 20. So that's how you solve a, we call them joint variation. It's a mix of direct variation and inverse variation and different power. So we have two more problems to go over. The first is problems of a distance. So look at the first sentence. As that the distance fall, I think in meter, vary directly to the square of time, t. So as I think that we should just give it a name, t. So we would say as vary directly square of time. So that's what we do. And you have an object for 19.5. So this is the distance for, and 2 seconds is the time, right? So this is t. So we will always be given a set of known number, 19.6 meter, k, 4. 2 square is 4, right? 2 square is 4. So then k would equal to 19.6 divided by 4. So we still do 1, 2. The step 2 is always solving for k. 19.6 divided by 4 is 4.9. I think this is a known gravitational constant that we know. And then the step 3 would be, we can actually have the formula 4.9 t squared. So how long would it take for it to fall 318 meter? So this is not time, it is meter, so it is s. So if it is 313.6, what would it be time? Right, so what was t? So you divide it by, so you would say t squared is 313.6 divided by 4.9, and then you square root it. Okay, 313.6 divided by 4.9. So what would that be? So t would equal to square root of 313.6 divided by 4.9 is 8. So in 8 seconds, it would fall 313.6 meter. Last example is the number of hours required to paint a house is inversely proportional. So they don't have any variable, so we just invent some hours. We say h. To paint a house is proportional to the number of workers, so we'll say w is the worker. Okay. So hours is equal to k over w, right? Inverse dividing. If it takes 3 people, so this is the model. The second is to solve for k. So 3 people, so that means 3 is w. 10 hours, so this is h. So we have 10 here, k over 3, right? So if you solve it, it's 30. Number 3, you can write the equation. Hours is equal to k over, no, k is 3. K is 30, no, not 3, 30 over w. So now, how long will it take 8 people? So 8 people, that means it's w. So it's 30 over 8 would be h. So 30 over 8. I think divided by 8. So that would be 3.75. It would take 3.75 hours. So if you only have 3 people, 10 hours. If you hire a lot more, 8 people, then it's 3.75 hours. So rounded to decimal places. And that's all of 5.8.